Hello and welcome to this video on the ICND1 series. In this video, we will be looking at access control lists. So we're going to look at how access control lists work and the types of access control lists that we have. So what are access control lists? They're just lists that are used to match traffic. So what you have is a list of permit and deny statements. And all these statements do is say, okay, they match a particular set of traffic, and then based on the traffic that is matched, you can now apply decisions. So for instance, if you have the criteria that the source of the traffic must be from the 192.168.1.0/24 network, I can have an access list that says permit all traffic that is sourced from this particular subnet. And then I can decide what I want to do with that traffic. By default, access lists have two actions. They can either permit or deny. In access control, what you do is you apply the access list to a particular interface, and based on the entries in the access list, you would decide whether to permit traffic or to deny traffic. But access lists are also used for other things. For instance, they can be used for network address translation. So if you have an access list that is defined and is used for a NAT entry, then depending on the addresses that are permitted in the access list, those are the addresses that will be translated. So in that case, access lists are only used to decide which traffic will be translated. Access lists are also used for other features. For instance, it can be used for quality of service. In quality of service, you just specify a group of IP addresses and decide the way the traffic will be treated based on policies. So there are different uses for access lists, but the most common use for access list is in access control. And as far as the ICND1 series is concerned, we are only going to be exploring access lists for access control and for NAT. Now let's look at how access lists work. Like I said, an access list is a list. So for instance, this is an example of an access list written in plain English. So you can have some like permit 192.168.1.0/24, which means that you should permit any IP address that is sourced from this subnet. And then it has another entry that says deny 10.1.1.1/32. And /32 means that it's a host address. That means that it's only going to match the 10.1.1.1 IP address in itself. And the last one is to permit 10.1.1.0/24 subnet. So now, for instance, if we have traffic coming from 192.168.1.5, what's going to happen, it would go through the access list, and the list is read from top to bottom, which means that it's going to go and say there's a permit statement for this subnet, and it's going to check if this address is in this subnet. And because it's in this subnet, what's going to do is going to permit it. So this will go through. If you have another IP address, for instance, 10.1.1.1, what's going to happen is it's going to go through the list again from the top to the bottom. So it's going to say permit 192.168.1.0, but this is not in that subnet. So it's going to come to your next statement that says deny 10.1.1.1. And since 10.1.1.1 matches it, it's just going to deny it. It's not going to get to the last statement that says permit the whole subnet. So in this case, even though 10.1.1.1 is inside the subnet 10.1.1.0/24, it's going to be already denied on the second statement. It's never going to get to the third statement. And what this means is that the order of entry matters. So for instance, if the access list was reversed and this statement would come before the deny statement, then it would have permitted this instead of denying it, because in this particular access list, the deny entry is before the permit entry. It's going to deny this particular IP address. Now, if we have another IP address that is like 10.1.1.5, for instance, it's going to go through it again. And it's going to go to the first statement if it doesn't match. It's going to the second statement, it doesn't match. So it's going to come to the third statement. It's going to say 10.1.1.0/24. Definitely 10.1.1.5 is part of that subnet. It's going to permit it. So what happens if you have like an IP address that doesn't match any of them? For instance, you have 172.16.1.1. It's going to run through the whole access list, and of course not going to match the first one. It's not going to match the second one. It's not going to match the third one. So what's going to happen is that it's going to get to the end of the access list, and then it's going to reach the implicit deny. So what that means is that at the end of every access list, even if you don't type it, there's a deny any. So if you rush through everything and doesn't see any permit, it's just going to take it as a denial. It's going to drop it. So if we configure an access list that is just supposed to block a particular set of traffic and wants every other traffic to be permitted, you have to go explicitly and type the permit any statement. So you're going to say permit any, and in that case, it's just going to permit everybody. So what happens when you put in the permit any is that the permit any is squeezed in before the implicit deny. And because of that, if you have like 172.16.1.1, you would be permitted with the permit any statement. It would never get to the deny any. So if you don't want an access list to always deny traffic at the end, what you should do is that you should put in the permit any statement at the end of all of the entries. Now let's look at how to apply access list. So I'm just going to clear the screen. Now assuming we have a router, and this is fast Ethernet 0/0, and this is fast Ethernet 0/1, when you have an access list, you can either apply it inbound or outbound. Now, inbound means that you're applying it before it enters the router, so going into the router interface, and outbound means that you're applying it as it's coming out of the router. The way to choose whether to apply it inbound or outbound depends on the source of the traffic and the direction. So, for instance, if I have a network here, and it's 192.168.1.0/24, for instance, and then I have another network here, and it's on the 128.1.1.0/24 network. If I want to match traffic that has been sourced from 192.168.1.0 network, that means the traffic will be sourced from this network, and it's going to come inbound fast Ethernet 0/1, but it's also going to go outbound fast Ethernet 0/0. So I can apply my access list inbound fast Ethernet 0/1 or outbound fast Ethernet 0/0. But if I'm trying to match traffic that is sourced from 128.1.1.0, when traffic comes from 128.1.1.0, it's going to go inbound fast Ethernet 0/0 and outbound fast Ethernet 0/1, because when it goes into fast Ethernet 0/0, the router will process it and send it out through fast Ethernet 0/1. So it depends on the position of the source and the destination that's going to determine where the access list is going to be applied. This may not make a lot of sense right now, but when you take more examples, you're going to see how to decide where to send in and out. We're going to see how we decide where to apply an access list. Now let's look at types of access lists. For the ICND1 exam, you are supposed to know 3 types of access lists. The first one is what's called the standard access list. The second one is called the extended access list. And the last one is named access list. Now, what's the difference between standard and extended access list? A standard access list is an access list that only matches with the source IP address. So when you have things like just permit a source address or deny a source address, it's usually a standard access list. And the way you know standard access list is the numbers. So when you have anything from access list 1 to access list 99, that's a standard access list. But after a while, the range access list 1300 to 1999 was also included so that you can have more than 100 standard access lists. Before, you could only have 99 from 1 to 99, but now you have extra 700 to add to that. So there's a wide range of access lists now, but it's still the same thing. Whether it starts from 1 or 1300, it will still be matching based on the source address. And the thing with the source address is that it doesn't give you a lot of information to match with. So for instance, with standard access lists, you can decide that you want to block HTTP traffic, for instance, or telnet traffic, because for you to do that, you must know the port numbers and things like that. Therefore, for standard access list, it only matches based on the source, and it's an all or nothing approach. So if you were to say, I don't want 10.1.1.1 to get to a network, it's just going to block all the possible traffic from 10.1.1.1. So all IP traffic will be blocked. It doesn't care if it's TCP or UDP or if it's HTTP or anything, but with extended access list, it matches with both layer 3 and layer 4 information. So what that means is that it can match with the source and destination IP address. It can match with the port numbers. So you can say that I don't want HTTP traffic going to a particular server that is on 10.1.1.1, and that you want to stop clients on the 192.168.1.0 network /24 from accessing the server. So this would be the source of the traffic. This would be the destination of the traffic. I know the kind of application, so you know that that's TCP port 80. So you can specify all this information in an extended access list. And the numbers for extended access lists is from 100 to 199. So you have like access list 100, access list up to 199, and you also have an expanded range, which is from 2000 to 2699. So normally the way a router used to recognize access lists would be with the numbers. Say if we just type access list 5, for instance, this is a standard access list, and we've typed access list 105, it knows that it's an extended access list. But later on, we had the concept of named access lists, where you could give access list names instead of numbers. So it's easier to know what they do. So for instance, I can say access list deny telnet. Now this is just a generic name. It doesn't matter what the name is. It's the entries of the access list that actually determine what the access list would do. But with that, you can specify whether it's a standard or an extended access list. So for instance, I can have something like IP access list standard. So I can say, for instance, deny guest. And what that means is that this access list I'm trying to configure is supposed to be a standard access list, and the name is deny guest. Now, depending on what entries I put in the access list, that's how the router is going to know what kind of action to take. It also depends on where the access list is applied. So if it's applied inbound fast Ethernet 0/0, for instance, or outbound fast Ethernet 0/0, and things like that. So in this video, we started looking at access lists. We've also looked at how access lists work, and we were able to look at the types of access lists that we have. In the next video, we're going to start looking at how we can configure an access list, and we're going to start with standard access list. Thank you very much for watching.